Hey, welcome back to BackBit Impossible. It's Loop here again, and in this episode, I try my pot merging characters. This is where I, take a character from the character set, find out where it is featured in the video matrix, and then go back to the original bitmap, pull out every, bitmap cell involved, and smush those together to create a new character to replace it. And it actually works kind of well. It's not the most exciting thing to watch, but it's effective. How effective? Well, you'll have to watch and find out. All right. Happy New Year. Yay. It's January 1, 2024. Now, I used a previous version. I hacked out chunks of it that I don't need. At the moment, it isn't doing what I want it to do or what I plan to make it do, but the first step does work. What I'm going to do is load in every single frame. This is SuperCPU disabled time because I want to get real results here. And, well, this is what it does. See, I can still browse through the file, right? But what I need to do is start at the very beginning, frame 0. Okay, here we go. And this is what it's going to do. Now the color RAM is, well, it's loading it in when it really doesn't need to, because that's part of that display routine. I only need to bring in the character set and the video matrix, really. But as you can see, it's just loading up the results, all the frames that I've already made, and just tallying up the mismatch. It has to bring in the original bitmap as well to the 8000 area to do some comparisons to. But when this is done, I'm going to get a big fat result for the whole bloody video after you grab all the data that it's comparing now. Do the merging of all the characters that share the same character code. So you go back to the original data, you find like every one that uses the character 0, and you merge those originals together, and then you rewrite the character 0. And you do it for character 1, character 2. And if it's an improvement all around, well, save it to, I only need to save the character set because the video matrix will be exactly the same. The color RAM will be exactly the same. So at the moment, in my 32K chunk for every single frame, 9K is the original bitmap. That's 8 plus 1, because the video matrix is the same. It is just 1,000 repeated bytes because it assumes a multicolor character set limitation. And then 4K for my first attempt. That's 2K character set, video matrix color RAM, and then 4K for my newer attempt, which is the one that it's using now, of character set, video matrix, color RAM. And then I can just add 2K past that to save the updated merged character set. So when I want to load to play this again, I would load the plus 17K character set and then the plus 15 video matrix and the plus 16 color RAM. Does that make sense? I hope so. It makes sense to me. But as it is, well, it's going to be busy. And I like how fast this is. Like, look at this little Blinkosaurus. Boop, boop, boop. Just going through the frames like crazy. And I know I'm getting real results. And in the background, you can kind of see what's going on with the color RAM. So that's kind of cool. But anyway, I'm curious how much improvement in pixel difference I can get by merging the characters. I imagine there's going to be some. But I also want to see the difference in appearance. So when I'm done this, I'm going to make a little clip of certain sections of the video the way it was and the way it can be. And we'll see if it's aesthetically pleasing as well. But anyway, yeah, that was 4 minutes of me just going blah, 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 blah. I'm sorry. Shouldn't apologize for this. The whole point of my videos is to show how I'm doing stuff. For me, for you, for the curious, whatever. I mean, you're watching, and I'm thankful for that. So thank you. And it actually finished and didn't screw up. So there's our totals for the entire video. Interestingly enough, as you can see, as the fade out happens, it's more likely to hit a perfect frame because of duplicates and stuff. And I'm going to sneeze. That's great. Maybe I'm not. Well, whatever. Okay. So yeah, let's implement the merging of the source where the characters, you know what I mean. I hope you know what I mean. And let's see if that number changes. Now you might be able to see these frames changing barely. I'm using the Super CPU here. I'm just going to get some frames changed. I'm putting them in a new spot, the 17K mark there for the character set, just so I'm not pooching anything, but it works, and it works well. I got I tried some trials, and the pixel difference is improved, maybe about 4%. So yeah, well, now that I got this, let's get out of here. Oops, I forget how to end it properly, but close enough. And there we go. What do I need to do now? Let's see here. I could probably do this with you on the phone. Let's see, Chairmake. Well, actually, oh man, I had the right program anyway. What do I need to do to change it? Hang on. Sorry. Slow this down. Load character set, video matrix, character set. We want to get the one, not here. It's now, well, it's another 4K beyond this. This should be all it takes. I know I'm fudging it, but I've fudged a lot of things. So let's assemble. Now, let's see. These are the frames that I just made, and you can tell because 5803, the average, unfortunately, has a dot in his eye, but that's okay. But so let's see. So if I go to 53802, there should be blank or bogus. Yeah, because it's fetching absolute zeros for the character set. So that's good. These are the only ones that I've made, right? And of course, this is why I got to do it powered off, because we're getting some poocha data. We don't want that. Too bad though. This is quite slow. Oh, there we go. That's all I got. So now I know I can get back in there at least. There we go. What do I need to do now? Well, I got to power down, shut this thing off, get it all started again in slow mode. But yeah, you'll see how slow this is because, well, let's see. Well, I'll slow it down and I'll show you some of the code. Perhaps I will break in and interrupt myself and actually give you a more of a show and tell style breakdown of how this code actually works, because this is complicated stuff. I'm surprised I did it, but it's not the fastest. But anyway, oh man, it's hard to explain. Even thinking back as I was putting it in, I'm like, what does this do? And I fudged what I needed to fudge, and I trusted myself that it still works. But this is pretty much it. This is the whole routine of what it's doing. Look for zeros, find them, whatever. I'm just excited to get this thing rolling. Okay. See you soon. Okay. Oh boy, I am very nervous, but I believe this code should work. Let's see. What do we got? So let's read it back, doing that rubber duck mode. Change the graphics. This is the merge. It loads it in, merges it. Just add our mismatch to ZZ. Change the color of the border while it's saving. Increases the frame, and if we're not done, we go back and grab the next one. Then we turn off the graphics stuff and show the results. This should be it. There, now it's real deal. It's really working. Look for changes. See, it's like a little sprinkling here and there. I'm just waiting for this little bit. Oh, it didn't fix it, but we're we're on frame 1 now. If anything, it should smooth stuff out. But how long does it take 9,000 of these to go by? Let's see, the stuff on her back. Is that going to get quickly changed? Maybe, like you see what I'm looking at, these little pieces, that doesn't look natural. Oh, come on! Why isn't it changing the pieces I want to change? You stupid thing. Whatever. Oh, I'll look at this later once it's done. Man, 9,000. We're looking at a few days worth of work here. Well, whatever. I'll just let it do its thing and see if it comes up with a better image when this is done. It's hardly making a dent, though. It really isn't. And the code itself is very complicated. Like, it's breaking down stuff by bit and adding them up. What a pain. But hey, that's what processors do, right? I'd much rather look at this guy and see how he changes instead. Even though the pixel difference is supposedly better, I don't know if it's worth waiting 2 days for. Here we are, about 15 hours later. Well, it should probably finish later tonight. But yeah, I don't know. I don't think this is making much of a improvement. Mathematically, the pixel difference, yes, there will be some improvement, but visually, not a lot. But now that I'm doing it and I'm this far in, I'm going to let it finish, of course. I want to see what the difference is. I was thinking of a different way, yet again. I have my original bitmaps. Well, what I can do is run through each frame, and this is relatively easy to do compared to this, and count how many of the bytes change from one frame to the next. And I guess that's part of the secret weapon there, is only change the bytes that change. And if there's fewer than, say 4,000 or 3,000 or 2,000, or, if very few change in a 24th of a second, it may be possible to keep up a very steady pace. You will have to make some keyframe adjustments, like when the scene changes significantly. You're going to have to be prepared for a whoomp of about, 10,000 brand new bytes, but I got a feeling that might be possible too. And then if I end up doing that, well, then the whole point of making a multicolor character set compatible bitmap makes no sense, because now I can just go through it with full color bitmaps. So I get to start all over and redo my original images. I love it. I love it. I'm such an idiot. Almost done, but I can't wait for this. It's, past 2 in the morning. I gotta get to bed. It's 5:30 in the morning. When I checked this, it was about 90 frames away. Now we're 20. Obviously, I have to wait. I can't go back to bed yet. There we are. Wonder what that competes against. What'd I tell you, eh? It is an improvement. 2.1% is better than 0.0%, eh? Yes. Well, in the next episode, as you might have guessed, I've got my sights on yet another of these little side quests. This one involves squares. Lots of squares. Yeah. See you there, eh?